Hello, my name is Franz Joseph B. Obsena, and we're Group 4, and we present to you a revised project proposal to implement face detection in Dell Suite to improve security. And thanks to my support from Tristan Oliver and Jerome Clyde for revising this group project so that we could able to improve our research. So starting from introduction is that face recognition is crucial for everyday interaction, communication, and other menial activities that let us lead daily social lives. Given the advancement of technology and the growing use of computers in daily life, it is imperative to design systems that can precisely recognize and detect human faces. To achieve the intended goals, we aim to offer a technique that can successfully detect and recognize faces. AdaBoost is used to cascade a lot of differentiating traits, which results in a powerful classifier that can correctly categorize photos. This ultimately results in precise facial recognition. Finally, precise facial detection is the outcome. Then, for further processing, the well-known local binary patterns are used to the research topic. The original LBP operator recognizes the pixels of an image by thresholding the polygon area around each pixel with its center pixel value and using the result as a binary value. Then histograms from each subregion are collected and concatenated to produce a single specially enhanced feature histogram. Using the feature histogram as one of the key distinguish factors, the SVM classifier finds the target image. As a result, the approach satisfies our demand to detect and analyze face photographs for several applications. Problem: the challenge of face recognition is to identify a specific individual within a group of images. The many variables that might lead to variation in two images of the same face make it more challenging to accurately identify faces. To correctly identify the target images, the following problems must be resolved, such as changes in facial expression, age, and appearance, such as with or without spectacles, and so on, changes in the scale position and in-plane of the acquisition geometry, the face's rotation, and lastly, changes in imaging including variance in lighting and cameras. Considering all these variables, we may evaluate the distinguishing qualities that make one individual stand out from another, producing a feature vector for each sample. Following processing, these feature vectors from the dataset are compared to the test or target images. The label that has the most striking likeness is the one that is meant to be applied to the image in issue. The objective is that our goal is to develop a system that can instantly locate and recognize faces in digital images derived from video output. The contour of the face and the area surrounding the eyes are two defining elements of the faces that are essential for identification and recognition. The following list summarizes the primary goals of the project is that our objective is to develop a face recognition system that can quickly recognize faces in crowded environments, reduce the influence of extraneous components as much as possible in real-time context. The next step is to provide our system with enough images after the face recognition phase is finished. Histograms must be obtained and concatenated for each subarea in an image before being used to create a feature vector for each image using local binary patterns. We want to evaluate different recognition algorithms, each of them balancing accuracy and rapidity. Solution: the numerous sectors which might benefit from face recognition. According to the result of our analysis, the proposition may be described as follows, such as the multi-class classifier accuracy may be enhanced, which will increase accuracy. Other additional approaches may be employed and compared to obtain findings for a large database with higher accuracy. To improve accuracy, we may apply it to a range of areas including surveillance. Methodology: the facial detection system for the campus is a system which works by identifying and measuring the facial features of anyone that will enter campus grounds. Before a person can use the system, they will have to be a student, professor, worker of the school, and will have to undergo a few steps for the system to recognize their faces. Once those steps are accomplished, the facial recognition system can detect someone's face before entering the school premises. And this is our project details. And as you can see here, we have a software requirements that we need specifically able to run this through, such as OpenCV and Python. And the hardware requirements we need is the web camera and Hikvision CCTV cameras for us to see and detect clearly from individuals' faces who are the members of our school or not. Lastly, this is our schedule, and as you can see here, and we started our project planning based on our schedules, and we start our first phase from analyze requirements, second phase system development, third phase coding, bug fixes, fourth phase implementation, sixth phase field testing, and last phase the product launch of our facial detection system that installed in our surveillance cameras. So yeah, project cost. The project of this budget costs nearly 94,000 pesos for four cameras or facial recognition systems, which is the reason why it is expensive is because we can are not very um, not very financially have lots of money. So we decided to able to get it for four in school entrances for us to enter as a member for our school or not. So yeah, this is our budget. In conclusion, this project evaluates whether the new proposed system is beneficial to the campus. If the system is not beneficial to the campus, it is not considered. The research also assesses if the system can be developed appropriately precisely on schedule using the resources at hand and according to all limitations. Technically speaking, face detection is possible since all a user needs to utilize the system is a web camera. To get more accuracy, we may apply it to a variety of fields including for both detection and security. Similar to how it is economically feasible, it is also operationally feasible due to how simple it is to use of this technology we propose. And that is about it from our group presentation, and I hope you find this very interesting from our work and our efforts. So see you next time.